Hey, you amazing lot. I hope you're doing well. Welcome back to Geo Cafe. Sorry it was a little bit delayed. There were some uh, technical problems in my setup. So sorry about all of that, but hopefully we can continue as usual now. You guys ready for your exam tomorrow? Must be nerve-wracking. Stress must be real. I can understand that. But don't worry, we're going to go through some of the work and see where I can help. So I was thinking we can maybe look at a few past papers. So I know that I have done a couple of favorite final videos. So I've done a few topics already. So I thought we could maybe focus on on the sections that I haven't covered yet. So like the fluvial geomorphology. So like there's a couple of little sections with atmospheric science that we haven't done, but maybe a little bit more on fluvial geomorphology and the river systems and that kind of stuff. And I thought we maybe look at the most recent IEB past paper or last year's IEB past paper and we can figure it out from there. But yeah, you are welcome to ask questions. Let me know where I can help. Okay, let me get the screen up. Great. Okay, so I thought we could maybe just start with last year's IEB paper and then figure it out from there. Um, I'm pretty much going to be doing this paper with you guys as we go through it. I'm not going to know all the memo answers, so I'm going to be answering it to the best of my ability. And you guys can see if you agree with my answers or maybe if I'm missing stuff, and we can then compare it to the memo answers and see how we do. Okay, so I believe IEB and CAPS, they are both writing their paper one tomorrow. But paper one for IEB and CAPS are different content. So for IEB, it's actually all the theory work, but for CAPS, it's mostly the physical geography, so atmospheric science and geomorphology. So I want to just focus on those areas and, just try to cover as much of tomorrow's work as possible. I can't actually do map work with you because I don't have the maps. So I'm not quite sure if I can revise map work, but well, we can figure it out. Okay, so I've just opened up that one and let me open up the memo as well so we can compare our answers. Great. Okay, so I did say that I've already covered quite a bit with tropical cyclones, mid-latitude cyclones, anticyclones, all of those areas. So maybe let's just see if there's specific questions that weren't covered in favorite finals. This very much looks like it's just relating to mid-latitude cyclones. All of this actually looks like what I've already covered. So I'm going to leave this section for now and see if we can find anything that's new. Um, let's see. All of these looks like questions we've already done. Okay, urban climate. That's actually something that we haven't covered for our revision. So urban climate, study the satellite image below, which shows two locations in Richards Bay. Okay, let's try this first and see how we do. Can you guys see that okay? Okay, so we've got two locations. We have a satellite image below. We have location F over here and location E. So I can already see that location E is supposed to be the urban area, the developed area. It's the central business district. And location F is supposed to be the more rural green area. Okay. Indicate the predicted temperature at location E. So in your rural area or further away from the urban area, you would expect it to be cooler because of the whole urban heat island effect. So I would estimate 21.6 degrees. Is there only two options? Yeah, so it would be the cooler one. I don't know. You guys agree? Okay, let's see if we're right. I don't want to show all of the answers. I don't want to give it away as we go through it. Okay, no, that's the previous section. Oh dear. Did I read the question wrong? I did! Okay, your first lesson. Read the question correctly. I thought it said at location F. It said location E. Okay, lesson number one. Read the question. I didn't. Okay, so at location E, that's the urban area. So yes, it would be the warmer temperature. I'm disappointed in myself. I've already lost a mark. So that would be 24 degrees. Okay, give a reason for your answer. Well, that's basically what I've already been explaining, that area E is the urban area. It's maybe made of materials that hold onto the heat more. It's only one mark. So I wonder if just like it's the urban area would be enough. Probably not. Um, yeah, it's an urban area. It's made of like a lot of concrete and cement and the tar roads and everything, which would, hold onto heat more, something along those lines. Let's see how detailed they want it to be. Okay, yeah, built up area, doesn't have greenery, doesn't have, okay, it's got artificial surfaces, so that's pretty much what I was saying. Built up, cement, concrete, tar. Any reasonable answer that indicates temperature increases, increased number of acorns, I suppose so, and lower albedo. Yes. Okay, so they were just looking for a general understanding, especially if it's one mark, you know. Using the line from location E to location F, draw a rough a temperature line graph. Okay, so let me get it right this time. So E is the urban area, F is the rural area. Okay, because in my mind, I would switch them around because they are the other way around over here. See, F is on that side and E is on that side. Okay, but look at this. If we go from E, so we would assume E would be warmer, so temperature would be higher because it's developed, it's urban. But as I move towards F, do you see what's happening over here? These are green belts. So it might even be a river. I can't really see with this picture, but that's a greenbelt area. So we would actually expect that to be a little bit cooler. So the temperature would be higher, then the temperature would drop, and then on the other side of the green belt, we've got a developed area again. Not as developed as the CBD, but it would be more urban, so it would be warmer again. So it would be high, dip down low, increase again, and then decrease towards the lowest at F. Um, Obviously, we're starting at E, so it would be high there, dip down by that green belt, increase again by that like almost look like an industrial, maybe business park area, and then decrease towards F. Does that sound about right? Okay, let's see what the memo says. Okay, yes, we got it. Yay! So I see they did allow marks for just decreasing towards the rural area. Okay, so I see they did acknowledge the whole switching of the axes, the fact that the F is on the side and the E is on that side. but you wouldn't have gotten 4 marks for that because you would still need to actually start by E and end by F. But yes, we were right. It is the highest at E. It decreases by that green belt. It increases again by that like industrial looking area, and then it decreases towards F. Okay, so far so good, right? So far, hopefully, it doesn't feel overwhelming. Let's have some coffee. Okay. Discuss 2 strategies the municipality could implement to reduce the effects of the urban heat island. So there we just have any type of greening of surfaces or of areas, maybe making surfaces lighter. It really comes down to those things. And what's the third one? More vegetation, greening, lighter surfaces, and I have forgotten the third one. Okay, but let's actually start to just discuss those a little bit. So let's say urban greening. So maybe you have like the roof garden idea, maybe planting more trees where possible, maybe making any types of surfaces lighter. So instead of having like dark tar roads, maybe using a lighter material or even painting it. You could paint buildings to be lighter colors so it reflects some of the heat. Um, I'm trying to think, what am I missing? So obviously loads of ideas. This is just off the top of my head. Okay, greening of the city, adding trees, adding parks, green belts, rooftop gardens. That's like a favorite. Um, oh, I didn't even think about that part. The emissions, so like car emissions and transport emissions and stuff like that. So maybe having more public transport, having different forms of transport could also reduce emissions and reduce pollutants. Decentralized business and industries. So the idea of basically moving businesses to more of the rural urban fringe. So less people have to get into the city for work. That could maybe lower emissions and that stuff. Remote working. So that also speaks to this idea. Reduce cars on the road. Industrial monitoring, tracking emissions from factories. So it does seem like they're quite open to ideas. I think you just have to actually explain your idea quite well. So as long as you explain how maybe greening, lightening of surface, any way that you can reduce emissions, as long as you explain how it works. Okay, and we finally get to the river section. Okay, so I know all of this is new, so let's actually just start from the beginning. We have a hydrograph and we have a flood. Okay. Which graph depicts a storm hydrograph in an urban area? Circle the correct label on the graph. Okay, so we have this like orange line here, and we have the blue one over there. We can see that River 2, the orange one, has a shorter lag time. It has a higher peak discharge. It has a steeper rising limb and a steeper falling limb compared to River 1 that has a much longer lag time, much more gentle, and much lower peak discharge. Okay, they want to know which one was an urban area. Okay, so urban area means that we have cement and concrete and a lot of impermeable materials, which means that water won't be able to infiltrate. It will wash off the surface very quickly and rush towards the river. So our answer would be River 2. That's why we would have a peak high river discharge because all of the water is rushing to the river very quickly. Okay. Do we agree? I hope. Let's take a look. Mhm. Yes, River 2. Fantastic. Can you guys see those answers? Should I zoom in a little bit more? Just remember what I can see on my screen is not necessarily what you guys can see. So just let me know. Great. Okay, give one reason for your answer. I always do this. I always give the reason before I give the answer. It's like at a certain point, these exam questions become very predictable. You know, you always have to choose a thing and then you have to explain why. Okay, reason for your answer. Urban area, impermeable material, less surface, less infiltration, more surface runoff, water rushes towards the river. Um, More surface runoff means higher discharge and shorter lag time because it doesn't actually infiltrate into the soil. Um, yeah, am I missing anything? Okay, let's take a look. Impervious surface, urban areas, don't absorb water, great. More runoff, good. Uh, Increased runoff. They mentioned the drainage systems, right? The drains and the gutters and everything can actually direct the water towards the river. So it peaks earlier. Reduce infiltration, channel modifications, drainage system. It really it's just repeating the same thing in different tones. Channel modification, changes to the natural river channel, like adding drainage, okay. Drainage systems, or yeah, basically quicker runoff, higher discharge. This one as well, they're implying changing of the land use, so urbanization means change of surface. You don't have rural vegetation or nice fluffy soil anymore. It's just a cement, concrete, and less infiltration. Okay. Okay, so we have a elevation map of Richards Bay. Okay, so we've got altitude. So blue would then be sea level. Okay. Red is along the coast. Okay. And then it gets lighter as it moves up in altitude. Okay, cool. We have a few water systems, a dam, a lake. Why do they even label them differently if there's no actual visible difference between the two? Okay. A marsh, a mudflat, a flay, non-perennial river, perennial river, and a residential land use. Okay. I would have thought that they'd put this in with the flood question earlier. It would have made sense. I could see this being a flood question. Okay, the average elevation of Richards Bay is, take the correct answer. Okay, so overall, I would say the color in general is that dark red. Maybe that more of a, maybe more of a peach. I'm thinking somewhere between that one and that one. What are you guys thinking? 10 to 20 or 30 to 40? Maybe one of those two? Oh, those are the options. 10 to 20 or 30 to 40. Okay, this is difficult. Wow, how are we going to do this? Oh, hmm. I'm thinking we go with the 30 to 40 if I just think about the meaning of average. average, adding up all the altitudes and working out the average. And obviously the higher areas over here, the 90s, 70s, 80s, that will bring up the average. So I was looking at, strictly speaking, I was looking at the mode. So if we're thinking in terms of average, maybe 30 to 40, because the higher areas would bring up that average. Does that make any sense? Okay, well, I'm gonna put my bet on 30 to 40. Let's see. Oh, oh, it looks like they accepted both. That's interesting. Hmm, that's interesting. So from the looks of it, the 10 to 20 was probably the right answer. So my initial instinct of look at the most prominent color. So the one that you see the most. But like I said, strictly speaking, that's mode, not mean, not average. So you probably had a lot of people saying the 30 to 40 because they were thinking average. They were thinking that the higher areas would have brought up the average answer. And they probably decided to accept, no, I don't want to show the other answer, accept 30 to 40 then afterwards. So the add 30 to 40 suggests to me that they decided to accept that one afterwards. So we are okay so far. We're getting it. I hope. We're passing. Hmm. Explain how the elevation of Richards Bay would influence the lag time and flood peak on the hydrograph indicated on the image. Oh, so it was a flood question. Okay, so they're asking how would the elevation impact a hydrograph for this river? The first thing I notice is that this whole stretch of river, I don't know if it's going into here as well though, it looks like it's on fairly low-lying area. And it also looks quite flat. So this area being the exception, this looks quite steep. See, it goes from this orange to yellow green quite quickly. So that looks like it's fairly steep. Maybe it's some type of mountain or something, or an escarpment. Um, this looks fairly flat. So I would assume gentle gradient means slower surface runoff and more infiltration. So a slower lag time, smaller peak, more gentle graph. I'm also noticing this is probably why they had the residential land use area over here. This area looks like it's built up, but nothing about this area implies that it's developed. So I'm assuming, completely assuming, that this is mostly rural or just, not built on, not developed. So that would also mean more infiltration, less surface runoff, more permeable material, so soil and sand and all of that stuff that water can infiltrate into. So more leaning towards low surface runoff, lower lag time, oh sorry, longer lag time, lower peak, more gentle graph. Does that kind of make sense? Like I said, I'm going in blind. I don't know the answers beforehand. Okay. Mm. Okay, but they were just looking at the elevation. Okay, so that part about the urban developed part that actually doesn't apply because they were just asking about the elevation. So then I would just lean into the part about the um, flatter land, um, you know, more gentle gradient, slower surface runoff, more infiltration, longer lag time, lower uh, overall total peak discharge. Yeah, I think that seems about right. Should we see what the answer is? Okay. Okay, so far so good. Lag time is longer, gentle elevation, rainwater will take time to infiltrate, large surface area, more infiltration. The peak will be lower, low flood peak, surface runoff will infiltrate, or run off into the sea. I actually didn't consider that part. That's also fair enough. It would run off into the sea. Much of the area is marsh or wetland. I didn't actually look at that. I probably should have looked at that. Gentle elevation, low floodplain. Okay, great. So we were on the right track. Let me see. Oh yeah, there it does say marsh. There it is. Okay, and mudflats there. There as well. Okay, so probably a lot of wetlands and stuff. Great. Fluvial processes. Now, I know this is actually a section that my students do struggle with. So let's make sure we have a good understanding of this as we move on. Okay, we have a whole bunch of empty blocks. We're going to have to label those blocks. Okay, we have a river. So we have two tributaries over here joining together over there. We can see the altitude, so elevation. We can see a little bit about the topography. We can see there's a lot of vegetation, a lot of greenery. Okay, I don't know if that's relevant yet, but I'm just making note of that. Um, I can see a steep side over here. Okay. I don't know why they didn't include contour lines on the side. You know, why do we have contour lines here, but not here? I don't know. Okay, and then a random yellow block labeled G. I bet we're gonna have to draw a cross section. No, maybe not. Okay. Label the blocks. Great, label the blocks. A tributary. Okay. Well, both of these are tributaries, and only the one has a block, so that one has to be A. That's a tributary. B, a confluence. Hmm. The only reason why I'm hesitating is because I'm looking at that block and that block. Uh, because we have a floodplain as well. And the floodplain looks like it could be here. Do you guys see? But I'm thinking it's actually this. I'm thinking this is supposed to be the floodplain. So if I zoom in a little bit more, you guys can see the change in color. You see, we have like this shrubs. So we have this line going along here, this dark green to a lighter green. And to me, that suggests that this area gets flooded. So I think this is supposed to be the floodplain, and this is the confluence. So this is where the two rivers or the tributaries join together. That's what I'm going with. So tributary, floodplain, confluence, and whatever the fourth one is. Let's go see what the fourth one is. Undercut slope. Okay, yeah, I that makes sense. Undercut slope, absolutely. Undercut slope is will be on the steep side of a meander, or the outer bank will be meander, and we do see that. Okay, let's see if we're right. Oh dear, I've probably given away some answers now. Uh, okay, A was the tributary. B, what was B again? The confluence. Yay, we got that one. And then C, floodplain, and that one was D. Great. Okay, we must try and not remember where any of those other labels were. Sorry, the dog is scratching at the door. I hear you. I do. Where is it? Where is it? Okay, what's that? Okay, fine. Hmm. He scratched on the door and then he walked away. Don't know what that was about. Okay. What, now you want to come in? Well, come in. Don't just stand there. Come. Up, up, come on. There we go. Up. There you go. Okay, settle there a bit. There you go. Yeah. Hope you don't mind. We've got some company. You want to leave again? Really? You want to leave again? You're just checking in, huh? Yeah, he's just checking in to see what I'm doing. Okay. It's fine. It's kind of sweet when dogs do that. You know, they pop in, just want to say hi. What you doing? Okay, so which way is the river flowing? Northwest, southwest, southeast, northeast. Is he scratching on the door again? I'm gonna ignore him now. So we can see that the tributaries are joining over here. So that means that it flows that way and that way. They join together and flow this way. So, okay, southeast, right? It's flowing towards the southeast. Yes. Remember, if this was wind, we would do it the other way around. You would name it from the direction it's coming from. Okay, so it's flowing southeast. Let's just double check. Yes, it's southeast. Okay, we have that yellow block. So we've zoomed in on that little yellow block. The fact that we have a line from I to J, just we're gonna draw a cross section. Like we know we're gonna draw a cross section. Okay, we have H on what looks like a braided meander or a braided channel over there, and K pointing to vegetation, I think. Okay. Complete the table by circling the correct answers to make each statement true. The river channel pattern is only one of these is actually a pattern. The natural levee and the floodplains, those are features. So even if you can't tell that that's a braided stream, that's the only one that's a pattern. Am I missing something? No. Okay, braided stream. Okay, H is an area of deposition. Definitely deposition. So the water slows down over there and it drops the sediment that it's carrying. Feature K, that must be a levee. I don't think it's a terrace. That must be a levee. So the levees are those little mounds on the sides of the river. So that one was simple enough. And transportation of the river load is suspension and traction, suspension and solution, solution and saltration. Okay, I'm not gonna lie, this one's tricky. So suspension is when you have these fine, like almost dust particles flowing through the water. Traction is basically where stones and pebbles and stuff roll along the ground. Solution is when it's dissolved, like it's chemicals and minerals in the water. And then saltration is basically when it bounces. So it picks it up and drops and picks it up and drops. Um, hmm. I do think suspension because based on the color, we've got quite a like murky light color. Um, so I would think some particles, dust, clay, that kind of stuff is being transported. But now the question is traction or solution? I don't think this river is flowing fast enough for traction. So the slower the river flows, the less material it can carry. So the fact that it does seem to be slow enough for it to be depositing material implies that it probably can't carry very heavy material. So I'm thinking suspension and solution. So either very light particles and maybe minerals and anything that's dissolved into the water. Yeah. Okay, should we check our answers? Okay, it was a braided stream. Good. It was deposition. And it was a terrace. It wasn't a levee. Okay, and suspension and solution was right. Okay, that was a terrace. Huh. I must say, I can't really see how we were supposed to tell the difference between the terrace and the levee. Because all we can actually see is this line running along over here, unless it was supposed to be clear that this is somehow a step. Like maybe if we look over here, that looks like it could be like a step down, and then over here again, another like little step down. Maybe that's what we were supposed to be seeing. Does that make sense? So it almost looks like a flat area there, and then a little cliff type thing over there, and then it's flat again with another cliff, and then flat. So maybe that was saying terrace. Okay, I suppose that makes sense. Draw a simple cross section from I to J. This is definitely one of their favorites. Okay. Make sure you have the right side of the meander on the right side of the diagram. I see this way too often. So I is by the deposition. Okay. So we can see that I has mostly deposition and J doesn't. So I would be a more gentle slope, and then J would probably be steeper like that. Okay, right. So they do actually say marks for the correct orientation. So making sure I over there is gentle and J is steeper. Good. Then the other thing that they were looking for is the island. We have to include the island in our diagram. So the river dips down from I, very gentle gradient. It increases again by the little island there. Then it dips down again and is steeper as it moves up to J. Okay, gentle gradient down, island, steeper, and steeper up again. So far, we're all good. Is this making sense? Is this helping at all? Okay, I hope so. I hope that I'm helping you guys study. Hmm. Explain how rejuvenation would impact the river channel pattern in figure 5. Okay, was figure 5 the picture that we were looking at? Yes. Okay, so rejuvenation can produce a lot of different features. So rejuvenation just means that the river would have more energy, it would be able to flow faster, so there would be more erosion. More erosion, so we probably wouldn't see this braided pattern anymore. We would have very clear terracing, maybe like okay, I don't think we actually have a valley to say a valley in a valley, but definitely very clear step terracing, a lot more erosion, maybe even erode that little island away. Um, yeah. Am I missing anything? The river pattern. It wouldn't be a braided river anymore. It would probably be a lot deeper, maybe somewhat more of a V shape or more of a valley shape. Oh, here we go. Okay, the braided stream and the deposition would be washed away due to increased energy and the river channel would become deeper. Okay, we're hitting all the notes. We've got this. Okay, and that was that question. I'm gonna leave the human geography section for now. I just want to go through all of the atmospheric and fluvial sections. And then I possibly want to hop onto a CAPS exam as well. I don't, yeah, let's take it one step at a time. We can always come back to these topics. Let me just zoom out, make it go faster. This is the essay question, don't need that. Lots of space for the essay. There we go. Okay, let's do some terminology. Oh, I suppose I should also get there with the memo. Don't look at the answers. Um, that's the essay. Okay. Provide a term for the following definitions. Write only the correct term in the space provided. Okay, definition. The anti-clockwise change in wind direction that occurs when a mid-latitude cyclone passes over. Okay, I always hate the wording of this because a mid-latitude cyclone, the wind moves in a clockwise direction. And now they're saying the anti-clockwise change. It's not blowing in the opposite direction. It's just where it comes from feels like it's changing. As the cyclone moves across, and imagine you're standing in one place and the cyclone moves across. The way the wind is blowing, in perspective to you, feels like it's changing. And in this case, it would be changing in an anti-clockwise direction, and we call that backing. Okay. Yes, backing. No, I should have the next answer. No, go away. Damn it. Okay, zone separating the cold polar air, the easterlies, and the warm tropical air, the westerlies. Okay, you guys saw the answer there. It's a polar front. So as a general rule, a front is any zone where two types of air masses meet. It could be dry air and cold air, hot air and warm air, and in this case, it's specifically the polar easterly or the very cold polar air and the warm tropical air. That is the polar front. Okay. Okay, occurs when there is an elongation of a low pressure cell. We did this one in the anticyclone's favorite finals. Okay, so where you have a long low pressure, we have a trough. So a trough, if you think about it, a trough is like what your animals would eat food or drink water out of. So it's like a dip between two high points. And those two high points would be like high pressure cells, and the low area in between is the trough. And a warm layer of air midway up a valley with cold air below as a result of an inversion. Okay, I'm glad I finished reading it because I was going to say an inversion layer. As a result of inversion of temperature. Okay, it's not an inversion layer. There's a different name for this one. Okay, so that little stretch of air, that would be a thermal belt. Oh, they still accepted inversion layer? But it's literally in the question. It's in the question. Okay. Oh, saddle. I actually haven't heard saddle. That's a new term to me. Okay, I did not know that. Okay, so we have polar front. We knew that one already. The trough, that was the answer that I used, and saddle. I guess I can picture that. You know, if you picture the saddle on the horse, you know, you've got the high part in the front and the high part in the back, and then you sit in the low area in between. So yeah, that would be the low, the saddle. Okay. And then thermal belt, and they also accepted inversion layer. That was a giveaway. Okay, but to be fair, some people probably got confused with that one thinking about it now, assuming that you couldn't use a word that was in the question. Okay, tropical cyclones. We have done tropical cyclones already, so I think let's just kind of skip most of this one. Drawing a diagram, they almost always ask diagrams. Yeah, we've done this one in favorite finals. I've used this specific picture. Okay, valley climates. That's a very nice photo. Okay, we have a beautiful valley. We have a campsite. We have an arrow pointing north. Okay, so that way is north. I wonder what that block is. I mean, I think we can already see exactly what this block is for, but I wonder what this block is for. Okay. Label wind O. Okay. I will admit this seems slightly confusing because it's daytime, but the wind is very clearly going down the mountain. Draw in the mountain breeze. Huh? Okay, let's start with the first one. Label wind O. So because it's going down, that tells me that the air is cold, so it was heavy, and when it's cold, it's katabatic. So katabatic, K is for cold. Draw in the mountain breeze. I must say I'm confused by this question because do they mean do they mean like it's going up the valley? No, sorry, I mean down the valley? Because how is it different to this? Okay, I'm gonna assume that they mean moving down the valley, or is it down the side? Okay, indicate if the wind at O is a day or a night occurrence. I can definitely see this confusing students because from the picture, it very much looks like this is daytime, but the wind is blowing down the mountain, so it's cold and it's cold at night. So this would be a night occurrence. Okay, I need answers for B because I don't know. Mm. Oh, okay. They did want you just to draw in the wind blowing down. I suppose yes, it would converge in the middle, but I was just thrown off by the fact that this wind was already there. So they wanted you to just draw in more arrows and then moving down the valley, I mean down the mountain. Yeah, it's supposed to look like it's coming down the sides and then along the valley. So down the sides of the mountain and like almost being channeled down the valley in the middle. Although that's difficult to draw. I'm not gonna lie, that's a difficult one. Okay, label wind O. We already said that's a katabatic. It's the mountain breeze is at the bottom of the valley, and is it day or night? It is night. Okay, great. In the morning, campers at the campsite will experience a frost pocket. Explain the conditions of a frost pocket by completing the following table. Calm, clear night. What are they asking you to explain? Okay, so they for there to be a frost pocket, you would need a cloudless night, so no clouds, and you would need no other wind, basically. So the only wind that would happen would be the wind that's generated by this valley climate. Um, so no cloud, definitely calm, no other wind. And the reason why you need it to be a clear sky is because of the terrestrial radiation. So basically, the radiation or the heat is released from the surface of the Earth and it's lost to space. So if there was any cloud or any type of cover, then it would basically trap that heat towards towards the ground or inside the lower parts of the atmosphere, and it would prevent it from actually cooling down as much as it needs to. Um, Yes, it would definitely happen in winter because that is when it's cold enough for something like this to occur. And I do also think if we're looking at where this is, yeah, we would probably be more likely to see clear, cloudless nights during winter and the movement of the air in the valley. So the air, the cold air that is getting so cold, it's losing all of that terrestrial radiation, losing it to a cloudless sky. That cold air would sink towards the bottom of the valley and basically make this pocket of very, very cold air. And like we say, because it's in winter, that cold air would be cold enough to freeze. And that's why we would have a little section of frost. And that little pocket of cold, cold air would actually push up the slightly warmer air, and then you might get a little thermal belt, a little inversion layer. Okay, let's see if that's more or less what they were looking for. Okay, cold air drains down the valley slopes, lower temperature at the bottom, no movement or disturbance in the air pocket. Okay, increases the formation of the inversion layer. Terrestrial radiation occurs with the mixing of the cold and the warm air and condensation on the valley floor. Okay, so they covered a lot of points in that one. Winter, the temperature needs to be below freezing point, so probably around below zero, depending on how humid it is. Um, so it actually has to be cold enough to freeze. That's kind of what we were saying. And then movement of the air in the valley. Um, so the warm air is displaced upwards. That's what I was saying. So all of that cold air that's sinking down and almost like pooling at the bottom, it would push that slightly warmer air up. So the warm air would be displaced upwards. It would create a inversion layer, stable. The warm air rises, the cold air sinks. Okay. Looks like we kind of understood what they were looking for. How are we feeling about this so far? Are we managing? Okay. Back to geomorphology. Back to our rivers. Okay. One of the questions they like to ask is for you to name the different parts of the drainage basin. So we can already see, looking at how they've labeled all of those different parts of the drainage basin, they're probably going to ask us to name them. Okay. Oh, that's the questions are predictable. Yeah, if I can give some advice before you actually jump to the question, just take a minute, look at the diagram and or the figure of the source or whatever you're given, and just figure out what's obvious. Just explain what you see. So almost imagine that you're explaining it to someone else, maybe someone that can't see the diagram or can't see the figure. So tell them what the figure is of and what information you can see from it. And by doing that, you're just establishing that baseline information in your mind before you go into the questions. So you have a a foundation of what you already know. And usually you're going to pick up things that you don't need to know, like that actually doesn't contribute to the overall answers, but it just helps give you a strong foundation. Okay, point P. Okay, there's P. Um, that just looks like a tributary. I'm pretty sure they've asked this question already. Okay. Yeah, I think that's just a tributary. Q. Hmm. Okay, Q's got me stuck, but let me explain. I'm trying to figure out if it's pointing. Let me zoom in so I can show you what I mean. Is it pointing to the land in between these two rivers, or is it pointing to where the rivers are joining? I think I think it's pointing to the land. Do you see what I mean? So it looks like it's pointing to this a little section in between the two rivers, not where they're actually combining. So where they join together, that is the confluence. We already had that in an earlier question. But the land in between these two tributaries, that would be an interfluve. Okay, so that's my answer for Q. I'm going with interfluve. Okay, R. Oh. Oh, now I don't know. Oh, now I don't know because now that could be. Oh. R could be the interfluve. I think I'm going to change my answer. I think I'm going to say that Q is the confluence and R, the land in between, there's the interfluve. What do you guys think? Yeah? Okay, yeah. I'm changing my answer. Okay, S. Isn't S also a tributary? Am I missing something? Or is it the source? Oh wait, is S no, source be up here? Maybe S is supposed to be the source. What do you guys think? Actually, source seems plausible. I don't think they would have the same feature twice. So I'm going with S is source. Um, and the random block is either the catchment area or the drainage basin. I'm going to go with drainage basin. No, catchment area. Usually, sometimes it's difficult to tell the difference between the two. Um, Sometimes they have to accept both answers when you can't really make it out. I'm going to say the catchment area because the whole thing, all of it together, is the drainage basin. The catchment area is literally the area that catches it, but all of the parts put together, that's the drainage basin. Okay, I think we have our answers, right? So we said P was a tributary, Q was the confluence, R was the interfluve, I said was source, and then the block is the catchment area. Should we see how many I got wrong? Okay. Oh my word. Guys, we got them all right. Tributary, confluence, interfluve, source, catchment area slash drainage basin. Yes. Yes. Okay, not too shabby. That is not too bad. How many did you guys get? Did you figure those out as well? I'm sure you did. Okay, let's try the next one. Calculate the stream order for T, circle the correct answer. It would be nice if I could actually write on this. I can't write on it. But what I would do is actually label each of them with their stream order. So let me go from the furthest over here.